Hello, my name is Zithia Potlery, and this is my Lab 4. So, the purpose of Lab 4 was to analyze different types of energy, how they correlate to the motion of a system. So, and specifically in this case, kinetic energy, spring energy, and gravitational energy are all analyzed. Um, our basic findings are that the predicted motion and observed motions for the spring system, which I'll describe soon, were very similar in both axes, the x and the y, with minor differences. And the change in energy in the system was around zero due to the law of conservation of energy, with probably some small discrepancies due to unaccounted for factors. The system initially starts out at 0, and is defined as the weight on the spring, and the earth, which is gravity. So some key concepts and formulas are basically just F equals ma, which equals delta p over delta t. The force of gravity, which is just 0, negative 9.8 times mass 0. The force of spring, the kinetic energy formula, and the gravitational energy formula. So the details of the experiment is that a mass, which is attached to a spring in a given video, was loaded up and then released, and the unorthodox motion of the spring was tracked by a video tracking software, and this was then analyzed by code that I will describe in the next slide. As you can kind of see, the code kind of accounts for all three different factors using kind of force. First, it calculates the initial energies for each of them, kind of defines that out, and then it calculates out the force. So calculates force gravity, force spring, force, and then the entire force net, and then it will then go on to update the velocity and position based on these forces, and then it will update the spring, and it will kind of calculate the spring potential energy based on some measurements that you give to L and L hat and S, which are all constants, or the length of the spring itself or the direction of the spring. And then it'll calculate energy changes, which is something that we're analyzing. So it's analyzing the difference in kinetic energy, the difference in gravitational energy, the difference in spring force energy, and then it'll kind of add all of those together to create one big change in energy equation. And then here is my initial position, which is just kind of given away by my video tracker software. I just implanted the value 17 and negative 57, which is the default values given by my video tracker software. And these are the results. You can kind of see that for both X and Y, it seems to very closely follow the model, and it seems to kind of increase in terms of how different it is as it goes on, just slightly, and that's kind of because of the way that period is calculated in our in the way I run my model. So period is calculated as an average, but it's increasing slightly as the average of these three oscillations, but it doesn't necessarily stay constant across these three oscillations. And you can kind of see here that total energy does not change, but there is kind of a transfer of energy between kinetic energy, gravitational energy, spring energy. So yeah, the models are extremely similar with small differences, likely being attributable to air resistance measurement issues and the nature of the way the model is calculated, particularly the period issue that I talked before, which is found to take an average of the oscillations. So the energy principle is definitely satisfied, as I discussed before, as the changes in spring potential energy are offset by changes in gravitational energy or kinetic energy, and they all kind of you can kind of see how the chart says that they all kind of cancel out. And then these are the average periods for x of t and y of t. You can see y of t is somewhat faster, and the difference is likely caused by the discrepancy in the way our model is calculated, since our k constants must be uh, different for x of t and y of t. So real life kind of disagrees with the way the model works, because you can see real life says that the average period for y of t is a bit faster, so we need to kind of update our model to have different k constants for y of t and x of t if we wanted to fix that. So that's all.